So I'm going to talk about the importance of data protection and zero knowledge for scaling Web3 adoption. There we go. That one. Right. So in terms of Web3 adoption frictions, I kind of want to highlight a new blockchain trilemma. In the top, we've got utility. Here we've got ownership and privacy. And if you have a think about the Web2 world, we've kind of, we got our utility, but mainly by giving up our privacy, and kind of we were the product effectively. And if you think about blockchain with Ethereum and the like, we've kind of we've got our ownership, and we've got utility with smart contracts, but we haven't got privacy. So we've been working at midnight, and by midnight we Input Output Global have been working for the last 5 years on trying to sort of perfect and trying to come up with a solution to this kind of this trilemma as to how can we give you utility, ownership, and also privacy. And so with that, I kind of give you Midnight. So Midnight's a new generation of blockchain that enables dApps that are basically private data and public data, and you can use both at the same time in a smart contract. So in terms of blockchain, we're building on the tried and trusted Polkadot SDK. So it's very battle tested, and everyone's well aware of it. We're obviously going to contribute back to where we can to upstream to the pull requests into Polkadot SDK to make it better for everyone. On the zero knowledge data protection side, we're using Halo 2 as the proof system with Pluto Ares curves and KT commitments. Don't worry if that's double Dutch to you. That's fine. We do all the hard stuff, and you just have to worry about writing the private smart contracts. So on the subject of private smart contracts, with the utility side, the key thing is also we want predictable fees, and we'll go more into that in a tick. So on the predictable fee side of things, this really is a big friction point we've got for blockchain, because if I want to do a blockchain project and I go over to my CEO and say, right, I want to do this blockchain project, he's going to say, great, how much does it cost? And if I can't really give a number for how much it's going to cost me over the next 2 or 3 months, then that's going to be a big fat no to getting the project signed off. So the key thing is that we need to be able to have predictable fees. And if you have a look at, say, Ethereum and Bitcoin, you've got the base token is linked directly to the fee token. So as soon as number goes up, you suddenly have high fees, and so it's kind of a built-in limiter to success. So as soon as it becomes successful, you've suddenly got this like high barrier to growth. So from Midnight's point of view, we're going to separate our proof of stake token from our shielded gas token. And I use the word shielded there. What I mean by that is just that you're not going to be, when you're making a transaction, you're not going to be, with your metadata, you're not going to be giving away private information as to the fact that it's you versus someone else who's doing that transaction. And then in terms of the next kind of things we're going to be doing is going to be capacity exchanges of being able to sort of lease, a certain amount of block space, so that businesses have that kind of knowledge that they're always going to have capacity on the blockchain, and gaseous transactions for users, so that the dApp can pay for the user's transactions rather than themselves. So that's it for predictability. I think predictability is and business certainty is extremely important for business growth. It's one of the big frictions of blockchain. And the other one I want to talk about and spend the rest of the the talk about is on privacy and compliant privacy. We've got an immature regulatory environment it's getting a lot better, even in the States. If you've been paying attention to the Agricultural Committee, that's starting to get a lot better, and hopefully over the next couple of years that will improve massively. But enterprises are still fearful of being on chain, and I guess rightly so, because at the moment you've got everything as public data, and that's, I mean, there was an example. In the corridor was like, can we do Airbnb on blockchain? So it's like, I don't want to give my address away to where I am when I'm going off on holiday. So we don't want to have everything public data. It's just not a good plan. So we need to find a sweet spot about having that public-private information. And then we've seen migrations with businesses trying to do private DLTs like JP Morgan chain, where it's kind of like that was kind of the best they could do with the tools they had available. But I think we could do. I think we've got the tools now to be able to do a lot better. So yeah, just to get this message home, rather than publishing the data when you're submitting a transaction, you're going to be publishing for the private data. You're going to be publishing proofs of that private data. So you're never actually going to be handing over your private data to the blockchain. So that means that your data is going to stay on your machine. So let's have a look at that in more detail. So we start off with the zero knowledge proofs are going to be proved locally, so that as I said, your private data never leaves your machine, because there's various blockchains where they said, oh, we can get some proving kind of farm to go off and do that for you in the cloud. But obviously, getting your private data to the cloud is no easy way to do that. So from our perspective, keep it locally, and that by locally that could be your own company rather than necessarily your own computer. That's kind of your choice. It's how you structure your data. In terms of programmable privacy, Midnight is basically allowing developers to find that sweet spot between having everything public, which obviously has the downsides that we talked about, to having everything private, which obviously has other downsides, like the user experience can be truly dreadful if absolutely everything is private. And you want to find kind of that sweet spot in the middle where the UX is pretty good. You've got some good privacy, properties there, and we're basically opening it up to the DApp developers to be able to do any of this. Don't have alarms in the middle of talks. It's not a good idea. Selective disclosure. So as well as doing that, you're able to hand over attestations about your private data to various third parties you may wish to give that. And so we'll be working on a suite of tools to kind of help people be compliant with various laws and regulations that you've kind of got to be compliant with. So the heart of Midnight is basically a paper called Kachina by Thomas Kerber and friends that was done a few years back. And it's all about having a clear separation of the private data from the on-chain public data, and being able to. So you have the public state, and then you'll have the private state that stays on your machine, and then you'll kind of have, rather than the private state, you'll have kind of witnesses to that private state that get sort of pulled in as you run through your smart contract locally when you're creating the proof, and then when you're doing the smart contract is being run by the blockchain, then those proofs are then checked. And then the appropriate change is happening on the public blockchain. And the important thing here is also that we're doing a UTXO model. So basically, the state around a smart contract is linked solely to that smart contract, so that you don't have this like massive morass of global state that can be changed by various different people. Instead, the state is just allocated to that smart contract, which means that you can make it parallelizable fairly easily. Although we haven't done that bit entirely yet, so that's on the coming soon category. So show me the code. Right. So we're going to have an example. So this is going to be a bulletin board where you can post one message at a time. Only one person can post a message. Anyone can post a message, but once you've posted that message, no one else can post until that message has been taken down by the person who's posted it. So we'll kind of see. Here's a good example. Right. So as we talk about, we have some private state here, and then as you execute the smart contracts, you'll have a private state witness that is being pulled into the proof as it's being created, and then that proof is being put on the onto the blockchain and is being verified, and then along with public statements of things that you that aren't private as inputs. And then you have the public ledger state going from the previous state to the new state, and then you also have your private state being updated and the like. So let's see the code, right? So hopefully this is big enough that you can just about see it. But we've basically got an enum of whether or not the bulletin board is occupied or not. We've got a message for what you want to say in the message in the bulletin board. We've got a counter to say how many times has this bulletin board been posted to, and we've also got the kind of like the public key of the person who's posted to the bulletin board. So that's kind of the public state. So that's as we could think about it on the right hand side. That's going to be kind of what's on the blockchain as far as it's going to be attached to that contracts state. And then in terms of the circuit, or effectively the function that happens. So we have this export, which means that everything is generated, and you've got TypeScript bindings to everything. I should point out this is a smart contracting language called Compact, and it's not TypeScript, but it's gradually getting more and more TypeScript friendly. So you'll see over a little bit of time that it gets even more TypeScript like. But at the start, we have the assertion here that the ledger state needs to be vacant. So that's going to be proved by the blockchain. And then the next bit, which is quite interesting here, you've got this public key that is created by a combination of the public state of the ledger instance of like how many times you've posted to the bulletin board, and also this private state of the local secret key. And so, I guess what you've got to appreciate here is that this is where things can go wrong, right? You've got private information, and you're now able to muck about with it and potentially have errors. So the key thing is, obviously, from a user's perspective, you only want to use audited and well-known contracts. And from a coder's perspective, obviously, writing TypeScript code is fairly straightforward. Writing smart contracts is a bit harder, and writing contracts where you have to think about what do you want public, what do you want private, that side of things is a little harder still. You've got to think about it because you don't want to accidentally leak information. And so this local secret key, rather than being a call to another circuit, this is actually a call to this witness. Now, this is obviously the private data that won't ever leave your machine. And at this stage, we don't have to worry about compact code anymore, and we move into the standard TypeScript language. So this is just standard TypeScript at this stage. And so now we have this private state of the bulletin board, which has just got our secret key in this case. We've got a map here of the witness context, so you could use any of the private data, any of the public data in order to do this function. But here's where we return the secret key, and then also we potentially update the private state. We don't in this case, but we could do. But that is it, kind of in a nutshell. That you've got. In most cases, you're dealing with TypeScript and the TypeScript bindings, so you don't have to worry too much about the zero knowledge circuits once you've written those bits. From this kind of Goldilocks of being able to use private data and also public data, and you should be able to find that sweet spot. And we believe that should open up an awful lot of different use cases that just aren't possible today, or with the current everything public blockchains. So in terms of where we are on the roadmap, we're basically we've got a DevNet, and that's available for you to have a go at right now. We also have a testnet coming very soon, although I'm not allowed to say when. With that testnet, we're going to have snark upgradability. So one of the things is that obviously zero knowledge moves at a pace, as I'm sure you've seen in quite a few of these talks. And as such, we're trying to be as upgrade proof as possible. And in that case, because of that, when we're storing the Merkle state, we're doing that all as SHA-256 rather than storing it against one particular type of field size, for example. So that's one way in which we're trying to be future-proof. And then in terms of mainnet, we're going to be on mainnet next year. And then after mainnet, we're looking at trustless bridges. We're looking at zero-knowledge recursion, which as soon as we got this Halo 2 system, once testnet lands, we're going to be able to. That's going to enable the zero-knowledge recursion. So that's going to be having many transactions that instead of having to do them all at once, you could, and them taking a lot of space, you can just create one rolled up transaction that takes a lot less space and thus is a bit cheaper. And then the last thing I really want to bring attention to is this multi-resource consensus. So at the moment, in terms of our security, we've got Cardano as our security layer. So they're effectively, we're like a layer 1.5 as a kind of side chain to Cardano at the moment. But what we intend to do is to kind of branch out. So at the moment, we're completely proof of stake, but the idea is to be proof of stake, potentially a bit of proof of work, hopefully proof of useful work, and to allow things like AI trading and the like. Now that's still the research guys are still working heavily on that, so it's still in the beyond category, but that is our plan. So yeah, I think that's the main side of it. So the main thing is to go to docs.midnight.network and have a go at some of the example dApps. So the bulletin board example is there. It's it's in great detail with all the steps, so you can see in much better detail exactly what's going on there, and you can run it on your machine and see that I'm not just pulling the wool over your eyes. And then we've got loads of people on the Discord, so yeah, it's a great place to ask questions and to find out more about the project. So I think that's about a wrap.